The intensity of an electromagnetic wave is related to what we perceive as the intensity of the radiation or the brightness of the radiation. Okay. Um, the precise definition of intensity is it's the energy that's delivered per unit time per unit area. Now, energy per unit time is also known as power. So, intensity is power delivered per unit area. Now, how is the intensity related to the amplitude? It's given by this equation right here. Intensity is 1/2 times some constant known as epsilon naught. It's also, which is called the permittivity of vacuum, and it has this value right here, 8.854 times 10 to the negative 12 coulomb squared per Newton per square meter. So that's epsilon naught right there. C right here is the speed of light. That's 2.998 times 10 to the 8 meters per second. And the square of the amplitude. Okay, so if you multiply 1/2 epsilon naught C and the square of the amplitude, you get the intensity. The unit for intensity is energy per unit time, so joule per second per unit area, so per square meter. So joule per second per square meter. A joule per second is also known as a watt. So a big W here is the official abbreviation for a watt, which is a joule per second. Let's look at this example right here. Let's say you have a 5 milliwatt laser beam that has a cross-sectional area of 2.00 millimeters. So you have a beam with an area of 2.0 millimeters squared. What's the intensity of the beam? Power is 5 milliwatt. Okay. You can see watt is a unit of power, so your power is 5.0 milliwatt, so that's 5.0 times 10 to the negative 3, that's milli, and watt is a joule per second. So that's your power. So what's your intensity? Well, intensity would just be power per unit area. So 5.0 times 10 to the negative 3 joule per second, or watt. And your area is 2.0 millimeters squared. So 2.0 milli is 10 to the negative 3, so 10 to the negative 3 meter squared. Okay, so let's calculate that. We have 5 times 10 to the negative 3 divided by 2 divided by, that's 10 to the negative 6, so 1 times 10 to the negative 6. And that gives you 2.5 times 10 to the third. And the unit here is joule per second per square meter. Okay? Joule per second per square meter. That is your intensity. Now, so there's your answer right there. 2.5 times 10 to the third watt per square meter. Joule per second is a watt. Now, can you calculate the magnitude of the electric field wave? Then you're going to have to relate that to the equation, which is S is equal to 1/2 epsilon naught C times E naught squared. So if you know your intensity, you know epsilon naught, you know speed of light, epsilon naught's permittivity of vacuum, we can solve for the amplitude of the wave. So let's solve for that. You multiply both sides by 2, divide both sides by epsilon naught and C, 2 epsilon naught, 2 over epsilon naught times C. That cancels epsilon naught and C and 2 from the right-hand side. And you can see E naught squared is 2S over epsilon naught times C. And so the amplitude E naught is equal to square root of 2 times the intensity divided by epsilon naught times C. So that's 2 times 2.5 times 10 to the third, a watt per square meter, divided by epsilon naught. What's epsilon naught? We have epsilon naught is 8.854 times 10 to the negative 12. Okay, and the unit is coulomb squared per Newton per meter squared. Okay, and our speed of light is 2.998 times 10 to the 8 meters per second. Okay, so that gives us 2 times 2.5 times 10 to the third divided by 8.854 times 10 to the negative 12. Okay, divided by 2.998 times 10 to the 8th equals that, and you take the square root of that, so root 2, that gives you 1,372. Okay, and what's the unit for this? Electric field is a force that a charge of one coulomb would feel at a given location. It's a Newton per coulomb. Okay, so if you work out the units here, you're going to get a unit of Newton per coulomb. In base units, that would be kilogram meters per second squared per coulomb. Okay, Newton is mass times acceleration. So 1,372. Okay, or 1.37 times 10 to the third newtons per coulomb.